So in lesson 5, we are going to tackle what are called complex Boolean statements. And that's pretty much just as it sounds. They're still Boolean statements, which means they are still true or false, but now they're just more complex. So your goal by the end of this lesson is that you'll be able to use complex Boolean statements in Python, and that you'll be able to communicate when they are necessary and why they exist. So right now, even though we've learned about if, else if, and else, we're still pretty limited. So say, for example, that we wanted to write a program that takes in 3 numbers, positive or negative, and determines which number is the highest. Right now, we don't have the capabilities of doing that given our current situation, as we can only make a comparison between 2 items at a time, and it's either going to be this one's bigger or this one's bigger, and there's no way to compare it to a third. So this is where complex Boolean statements really come in. They allow us to do more with our true and false statements. So when I asked students to solve that program on the previous page about enter in 3 numbers and find the highest one, they typically tell me that this is what they would like to do with math symbols. They'd like to take this value is greater than or equal to this value is greater than or equal to this value and say, woohoo, so value 1 is in fact the biggest. Problem is, this is not allowed in computer science. That is not valid code. But on the plus side, this is exactly why Boolean statements were created. So Boolean statements help us when we want to compare multiple things at once, but can't using our typical math symbols that we would like to use. So far, we've learned simple Boolean expressions. And remember, at their core, Boolean expressions are things that evaluate to be true or false. And all of our previous examples were just simple one-step ones. X is less than Y. Z is equal to A. And what we're going to do today is we're going to now expand our knowledge of Boolean statements. They will no longer be simple, but they will allow us to have more power and have more strictness and specificness to our Boolean statements that go inside of our conditionals. So, complex Boolean statements, the idea behind them is that we're putting 2 or more, notice, or more, you can put more than 2, simple Boolean expressions together. So these are comprised of simple Boolean expressions, and we're going to tie them together using very specific computer science words. And by the end of this, you'll have an idea, or you'll start to be able to think through how to solve that maximum number problem that I showed you on one of those first few slides. So the first type of complex Boolean statement that we're going to look at is called a conjunction. And typically, this uses the word and. So a conjunction basically says that this needs to be true, and this needs to be true, and this needs to be true. And as a result, it's only true when all of its simple Boolean expressions are also true. So for example here, this statement would only evaluate to be true if x was less than 2 and y was less than 3. And what happens is if one of them is false, the whole thing ends up being false. So that's how a conjunction works. And we can write code that says this and this and this. All of these must be met. All of these simple Boolean statements must be true in order for my code to run. So I want to model what this looks like because sometimes this is a more difficult concept for students to comprehend. So here we have 4 different pairs of numbers, and what I'm going to do is I'm going to put them all into this same complex Boolean statements. Notice we have a simple Boolean statement connected by the word and with another simple statement. Remember, and means that they all need to be true. So for example, in this first one, we have x is 1 and y is 4. So 1 times 4 says 4 is greater than 4, and 1 plus y, so 1 plus 4 is 5, 5 is equal to 5. So what's happening here is we get a false statement and a true statement. And when we have a false statement and a true statement, this whole complex Boolean, because it's an and, evaluates to be false. And then if we go to the next one, okay, 2 times 3 is 6, greater than 4, and 5 is equal to 5. So this one is true and true. So we have 2 statements that are evaluating to be true, connected by that and. True and true results in a true Boolean statement. The next one we have 3 times 1, so 3 is greater than 4, and 4 is equal to 5. Those are both false. Because it's false and false, they both evaluate to be false. And then this last one, we end up with 9 is greater than 4, and 6 is equal to 5. So we have a true statement and a false statement, and because one of them is false, the and, or the conjunction, evaluates to be false. So what I'd like you to do on this slide is I'd like you to pause the video and I'd like you to try these 4 in your notes. See if you can accurately decide, okay, how will this and complex Boolean statement actually be evaluated? Will it be evaluated to be true, or will it be evaluated to be false? So pause the video, try them out using these values for x, y, and z. All right, so hopefully you gave those a try. As you look through here, you'll notice we have a true and a false, which results in false, true and true, which results in true, false and true, results in false, and false, which results in false. So hopefully those went well, and you have a better idea of how those and complex Boolean statements work. And just as a side comment, because I have a lot of kids ask about this after we learn complex Boolean statements, is the and is actually how we express a range of values involving two inequalities. So this is a common algebra concept where you say, okay, 5 is less than x is less than 10. And this, unfortunately, is not something that is valid in code. But in Python, what we can do is we can write it as two simple conditionals split using the word and. So notice here I still have x on the bigger side of 5, and I want x on the smaller side of 10. So I'm able to actually have that range of values using those two inequalities, and I'm able to represent that in Python by using that conjunction with the word and. So the second type of complex Boolean statement that we have is called a disjunction, and it uses the word or. So basically what happens here is you just need one thing to be true out of a multitude of things in order for your code to run. So it's true when one or more of the expressions are actually true, and is only false when everything is false. So it's this or this or this or this needs to be true, and if one of these is true, then all of the code will run. So notice it uses the word or instead, and it's slightly different than the and. In the and, you need all of it to be true or it's false, and here you just need one part of it to be true, and it will still evaluate to be true. So to model this for you, I'm going to use that same thing from before, and we're going to have the same values and just show you how the or evaluates differently than the and. So here we have x is 1, y is 4, so we plug that in and we have 4 is greater than 4, or 5 equals 5. So this is a true and a false together. So we have false or true. And because at least one of them is true, the whole thing, the whole statement evaluates to be true. Then this next one, we have 6 is greater than 4, or 5 equals 5. So that's true or true. Because they're both true, the whole thing evaluates to be true. Here we have 3 is greater than 4, or 4 is equal to 5. So that's something where we have false or false, and since both are false, the whole thing evaluates to be false. There's nothing true in there, so it can't evaluate to be true. And then the last one here, we have 9 is greater than 4, or 6 equals 5. So here we have a true or a false, and because one of them is true, the entire thing evaluates to be true. So see the slight differences between and or complex conditionals. So what I'd like you to do on this slide is, in your notes, use those 4 statements and their ors that are in there, and evaluate whether or not these statements would become true or false depending on these values of x, y, and z that are given to you. So evaluate them, pause the video while you're doing that, and then check your answers on the next slide. So check through your answers, see how you did. Hopefully you notice that if there's any component that is true, it evaluates to be true when you have an or in there. So different than an and. The only time an or evaluates to be false is if you have all statements that are false. And the last little piece of information that I want to give you is oftentimes to make things more clear, people will use parentheses as they use their conditional so they can clearly see it's this or this and this. So you're not required to use parentheses, but it's a good practice. It can help you to keep your ideas straight if you struggle to read the code like it is over here on the left. So up to you, but it's always an option.